So let's do exercise 2.2. So the problem states, let x and y be vectors in Rn. Prove the Cauchy-Schwarz inequality, that the absolute value of the dot product of x and y is less than or equal to the product of the magnitudes or the norms of x and y. Hint, you may find the geometric definition of the dot product helpful. So we will begin with that definition. So from the definition, the definition states that the dot product of x and y is just the norm of x multiplying the norm of y, another bar there, times cosine theta, where theta is the interior angle between the vectors. So that is the geometric definition of the dot product. Let's take the absolute value of both sides of the equation. So absolute value of x dot y is equal to the absolute value of the norm of x times the norm of y times cosine theta. So we can use the multiplicative property of the absolute value to say that that is just the absolute value of each of these terms in the product. Now, the absolute value of the norm of x and y are just the norm of x and y, so we don't have to, fortunately, triple bar those. That would be ridiculous, right? So the norm of x, the norm of y, times the absolute value of the cosine of theta. Now let's make an assertion. I think it's fairly clear, but we'll assert that the absolute value of the cosine of theta is less than or equal to 1. Okay? So if the absolute value of the cosine of theta is less than or equal to 1, that means that this term here is less than or equal to 1, which means that it will always make this term smaller. Okay? We can conclude, therefore, the absolute value of x dot y is always less than or equal to the absolute value of, or the norm of x times the norm of y. And that's clear because we can compute the absolute value of x dot y from this expression. And this expression, when theta is equal to 0, when cosine is at its maximum, when cosine is at 1, it's simply equal to the magnitude of x and magnitude of y, or the norm of x and times the norm of y. And we get equality here. If cosine theta is anything less than 1, which it is for values that are not 0 and pi, etc., then we have a term over here that's going to be less than this norm of x times the norm of y. Could say Q, E, D. All right, thanks for watching.